In this video, we will be discussing the solutions of all the MCQs of probability which are there in the Maharashtra government textbook 11th standard maths part 1. So let's begin. There are 5 girls and 2 boys. Then the probability that no 2 boys are sitting together for a photograph is what? So if there are total of 7 people, then 7 people can rearrange themselves in 7 factorial ways for a photograph. Now they are saying that no 2 boys are sitting together. So first you keep the 2 boys aside and you let the 5 girls rearrange themselves, and that can be done in 5 factorial ways. Between 5 girls there are going to be 6 spaces, and the 2 boys can rearrange themselves in these 6 spaces in 6p2 ways. So the final probability will be 5 factorial gets cancelled with 7 factorial, and you only have 7 into 6 remaining in the denominator. 6p2 will be 6 into 5. So you can cancel off 6 in the numerator and denominator, and 5 by 7 there will be the right answer. We go ahead with question number 2. In a jar, there are 5 black and 3 green marbles. Okay. So 2 marbles are picked randomly one after the other without replacement. What is the probability that both of them are black marbles? So in the jar, there are total 5 plus 3, 8 marbles. So the total number of selections that you can have are 8c2. And you need the probability of both of them being black marbles. There are 5 black marbles. So 2 out of black marbles can be selected in 5c2 ways. So the numerator is 5 into 4 upon 2 into 1. The denominator is 8 into 7 upon 2 into 1. So that 2 into 1 in the denominator of numerator as well as denominator gets cancelled. And finally you have 4 getting cancelled with 8 here. So this will be 5 upon 14, and that tells you option A is the right answer. Going ahead with question number 3. 2 dice are thrown simultaneously, then the probability of getting 2 numbers whose product is even is what? See, the product will be even if at least one of them is an even number. If one is even, the other is odd, the product will be even. One is odd, the other is even, still the product will be even. If both of them are even, then also the product will be even. The product will be odd only and only when both the numbers are going to be odd. So we can say that this required probability is going to be 1 minus probability of both the numbers being odd. Both the numbers being odd means let's make 2 blanks, and we can say that the probability for the first number to be odd is going to be 1 by 2, and probability for the second number to be odd is also 1 by 2 only. So the final answer will be 1 minus 1 by 4, which is equal to 3 by 4. And yeah, that tells you A is the right answer. In a set of 30 shirts, 17 are white and rest are black. Okay. 4 white and 5 black shirts have been tagged as party wear. Okay, fine. If a shirt is chosen at random from this set, then the possibility of choosing a black shirt as, a black shirt or a party wear shirt is what? So they are asking us probability of black or a party wear. So we can write this as probability of black shirt plus probability of a party wear minus probability of black intersection party wear. So the probability that the selected one is a black shirt, that will be, okay, 17 are white, so the rest of them 13 are black. Probability of having a black shirt will be 13 by 30 plus probability of having a party wear. Party wear, there are 9 shirts, and probability of having a party wear shirt is 9 by 30 minus probability of black party wear. So black party wear is just 5. So the probability will be 5 by 30. 13 plus 9, 22 minus 5, making it 17 upon 30. Yeah, so that's your required probability, and D is the right answer. Going ahead with the fifth one. There are 2 shelves. One of them contains 5 physics and 3 biology books, and the other has 4 physics and 2 biology books. The probability of drawing a physics book will be what? So see, you can select either one of the 2 shelves. So probability that the first shelf will be selected will be, okay, let's put it this way. Probability of physics book from the first shelf, that is probability of P intersection 1, or you can have a physics book from the second, so P of P intersection 2. This will be P of P into P of 1 plus P of P into P of 2. Probability of having the shelf 1 will be half, and from it selecting a physics book. So there are 5 physics and 3 biology books. So the probability of having a physics book is 5 by 8 plus probability of selecting the second shelf is half, and probability of taking a physics book out of the second shelf will be 4 physics and 2 biology, right? So the probability 4 by 6. Probability will be 4 by 6. So this will be 5 upon 16 plus we have 2 gets cancelled with the 4 here and 2 gets cancelled with the 6 here. So we have plus 1 by 3. So this is going to be 15 plus 16 upon 48, and the right answer being 31 by 48. So yeah, B is the right answer for the fifth question. With that, try the sixth one. So we have two friends A and B apply for a job in the same company. Probability that A will get the job is 2 by 5 and chances of B getting selected are 4 by 7. The probability that both of them get selected. So both of them get selected means P of A intersection B, and you can say this is P of A into P of B. Okay, I know that we can do this only if the events are independent, and in case of two people getting a job in the same company, the event of A getting and B getting might not be independent of each other. So we can't really do this in practical life, but okay, as far as mathematics is concerned, we are assuming that A getting a job in the company and B getting a job in the company are two events independent of each other, which is why we are saying that P of A intersection B will be P of A into P of B. And yeah, just multiplying the probabilities, we have 2 by 5 into 4 by 7, which is going to be 8 by 35. So C out there is the right answer for the sixth question. Going ahead with the seventh one. The probability that a student knows the correct answer to a multiple choice question is 2 by 3. Okay. So probability that a student knows is 2 by 3, which means that probability that a student does not know is 1 by 3. If the student does not know the answer, then the student answers the question by mere guessing. The probability of the guessed answer being correct is 1 by 4. So probability of correct given k complement is 1 by 4. And if he knows the right answer, we will assume that he is marking the right answer. So probability of getting a correct answer given that the student knows the answer, that will be perfectly 1. Now they are telling us that given that the student has answered the question correctly, okay, we are told that the question has been answered correctly. What is the probability that the student knew the answer? It is given to us now that the answer has been correctly answered. Now, given that the answer has been correctly answered, what is the probability that the student knew the answer? So they are asking us P of K given correct answer. And if you remember the trick for this, we used to write it as P of reverse of this. So P of C given K into P of K. The denominator will be P of C, and P of getting a correct answer will be P of C given K into P of K plus P of C given K complement into P of K complement. So we try to evaluate the full thing here to get the final correct answer. P of C given K into P of K. So that is 1 multiplied by 2 by 3. So it's 2 by 3 in the numerator. So this term is 2 by 3. So we have 2 by 3 in the denominator's first term. 2 by 3 as the first term of the denominator. And the second term P of C given K complement, which is 1 by 4 into P of K complement, which is 1 by 3. So 1 by 4 into 1 by 3 making it 1 by 12, and 2 by 3 plus 1 by 12, that will be 8 by 12 plus 1 by 12, which is 9 by 12, and 2 by 3 upon 9 by 12. So 2 by 3 into 12 by 9 is what that becomes. So we have 3 cancelling of 12, and yeah, 8 by 9 is the right answer for that question. So D is the right answer for your seventh question. Let's go ahead with the next one, which is a similar one. Bag 1 contains 3 red and 4 black balls, whereas another bag 2 contains 5 red and 6 black balls. One ball is drawn at random from the bags and it is found to be red. The probability that it was drawn from the bag 2. We will go a little quick with this because the sum is exactly the same. Probability of bag 1 or bag 2 to be selected is going to be 1 by 2. Then we have probability of it's red, right? Okay, so probability of a red ball given that bag 1 is selected, that will be 3 by 7. And probability of a red ball given that bag 2 is selected, that will be 5 by 11. They are already telling us that the ball is red. They are asking us probability of it being drawn from bag 2. So we are finding probability of 2 given that the ball is red. So we write it as P of R given 2, exactly the reverse of this, into we have P of 2. Denominator's first term will be the same very term, P of R given 2 into P of 2, plus it will be P of R given 1 into P of 1. Because ultimately, see, the denominator was P of R, and P of R can be written as P of R intersection 1 plus P of R intersection 2. That P of R intersection 1 is written as P of R given 1 into P of 1, and P of R intersection 2 is written in this way, that is P of R given 2 into P of 2. So let's try to evaluate these numbers. So we have P of R given 2 into P of 2, which is 5 by 11 into 1 by 2. In the denominator, the first term being 5 by 11 into 1 by 2. Plus we have P of R given 1 into P of 1, which is 3 by 7 into 1 by 2. So 1 by 2 in the numerator and denominator gets cancelled. In the denominator we have 5 by 11 plus 3 by 7, that's making it 35 plus 33, which is 68 upon 77, and that 68 upon 77 in the denominator can be written as 77 upon 68 in the numerator. So 11 cancels off 77 and we get 35 upon 68 as the final answer for that question, which is option D. With that, let's go ahead with the ninth question. A fair die, a fair is, okay, so they mean a fair dice is tossed twice. What are the odds in favor of getting a 4, 5, 6 on the first toss and a 1, 2, 3, 4 on the second die? So let's find the probability of the required event. Probability of having a 4, 5, 6 on the first toss, that will be 1 by 2, into probability of getting a 1, 2, 3, 4 on the second die, that will be what, 4 by 6, which is 2 by 3. So probability of the required event is 1 by 3. So one possibility supporting the event, 3 possibilities not supporting the event. So odds in favor, right? Odds in favor will be 1 supporting, 2 non-supporting. So odds in favor are 1:2. So C is the right answer for that ninth question. Read the 10th question. So we have the odds against an event are 5 by 3. So probability of the event is 3 by 8. The odds in favor of another independent event, so let's call this P1, let's call this P2. The odds in favor, okay, in favor are 7 by 5, so probability will be 7 by 12. The probability that at least one of the two events is going to occur, so we can say that the required probability will be 1 minus the probability of none of the two events occurring. So 1 minus probability of event 1 to occur 3 by 8. So not occur is 5 by 8 and event 2 to not occur is 5 by 12. So the answer is 1 minus 25 upon 96, and 96 minus 25, that will be what, 71 upon 96. So yeah, we have option B as the right answer for the 10th question. So yeah, that's where we are done with whatever I wanted to discuss in this video. I hope that the contents have been someplace somewhere helpful to you in your preparations. Thank you for watching.